In the previous video, we introduced the concept of an integral. We found an example in which taking a derivative yields the association rule f on x, which we integrated in the first place. The purpose of this video is to show that this result is general. We demonstrate the so-called first fundamental theorem of calculus, which states that taking the derivative undoes integration. We want to take the integral from x equals a to b of f on x dx and show that differentiating this object with respect to its endpoint b and then evaluating the result at b equals x naught returns to us the original function evaluated at x naught. To demonstrate this relationship graphically, we remind ourselves of the interpretation of the definite integral as the area under the plot of a function. For this illustration, consider a function with a generic plot like this one. To study differentiation, we will look at successively small differences between areas evaluated under the curve. The derivative of the area or the integral is the limit as delta x goes to 0 of the fraction whose numerator is the area associated with x naught plus delta x minus the area associated with x naught, and whose denominator is delta x. Choose this position for the boundary x equals a and choose this position for x naught. The area associated with x naught is the area of the region shaded in orange. The area associated with x naught plus delta x includes the area shaded in orange and an additional area shaded in red corresponding to the area under the curve between x naught and x naught plus delta x. The difference between the area associated with x naught plus delta x and the area associated with x naught is the area of the sliver shaded in red, which can be thought of as the combined area of this purple rectangle and this green wedge. As we shrink delta x, the purple rectangle and green wedge both get smaller in width. However, the green wedge also gets smaller in height. The area of the green wedge is doubly small and becomes an arbitrarily tiny, and thus arbitrarily negligible, fraction of the total area of the purple rectangle and green wedge combined. The area of the red sliver is thus approximated by the area of the purple rectangle, which has height f on x naught and width delta x. In other words, it has area f on x naught times delta x. Divide both sides by delta x. Assuming that the plots of interest are not horribly jagged, we repeat this line of argument for smaller and smaller but all the while finite delta x's, expecting the ratio of the difference of areas to delta x to become arbitrarily close to the derivative dA dB evaluated at x naught, and expecting the rough equality to become arbitrarily accurate. Since uppercase A is the integral from x equals a to b of f on x dx, we have confirmed the expression which we sought to show. The derivative of an integral spits back out the original function's association rule. In this video, we demonstrated that differentiation undoes integration. This statement is called the first fundamental theorem of calculus. In the next video, we demonstrate that the reverse is also true. That's to say, integration undoes differentiation.